So I'm Thierry Midavaine from Société Astronomique de France. Thanks a lot, Fabien, for welcome and invite me to present RAPAS. I already presented RAPAS last year, and so I would like to update what is the status today about this network. So it's a ProAm collaboration funded by also the Paris Observatory Scientific Council. We receive 3 fundings in 22, 23, and this year to pay filters, and last year to fund 2 spectrograph prototype. At the very beginning of the idea is we may propose an amateur network to answer to alerts. And at the very beginning, it was William Tullio from IMCC requesting help for asteroids alert coming from Gaia. And the idea at the very beginning was to use the nice thing coming from amateur telescope, and we realized yesterday that a lot of amateur telescopes today are in a professional program, gathering a lot of telescopes to cover a wide field of view. But in fact, these amateur telescopes are already existing. So why not plug these facilities in such a network? So we define a figure of merit for this telescope. We have seen that also yesterday with the idea of quoting the étendue géométrique of all the telescopes. And here the idea is to quote what is the upper limit magnitude an amateur is able to achieve in 1 minute exposure, and what is the field of view in square degrees is able to cover. And this gives us a quote for any kind of telescope, and maybe help the amateur to update its setup to enlarge this field of view and increase this quote. Today, we have nearly 63 observers registered. Some are from outside of France, but clearly the purpose is to have a French network. And so I would like to invite you to have in mind how you may create such a network in your respective country. Because of course, in all your countries, you have amateurs ready to answer to alert. Here are the location in France, in front of the dark sky quality we have in France, the location of all the observers. So the idea is also to show that all these telescopes spread over a large country may meet also the cloud coverage constraints. We make, there is always a clear sky, anyway, even in England, I'm sure, or even in Ireland. But it's really an issue in France. We have bad weather. More and more we meet such a bad weather. And so here is a histogram of the telescope according to the diameter. We start at 200 millimeter, and we have some telescope up to 800 millimeters in diameter. Here you see the field of view in a square degree. So we go to up to 3 square degree field of view coverage. Here is the étendue géométrique, square meter by square degrees. And here are some other cloud of to show the heterogeneity of the telescope. But we may deal with it. This is the reality. Today, there is only 25 telescopes equipped with the set of filters. Here are this telescope, and we monitor, are they ready to get a picture? They are colored in green, or are they in do they have a problem, not ready to record the data or ready in their time? So I put it in yellow or in red. So at the very beginning, the idea comes from Gaia. You know, the Gaia catalogs provide photometry in 3 bands, and these 3 bands are wide, and this gives us an enhanced sensitivity to small telescopes. But even for large telescope, this increase the sensitivity you may reach. And so at the very beginning, 5 years ago, I started to join some Gaia workshop, and I request, where are these filters? I would like to get it. And in fact, I realized that in fact there is no filter in Gaia. These spectral bands are given by the sensitivity of the CCD, and for the B part and the red part of the 2 second photometric catalog, GBP and GRP, this comes from a small prism in front of the CCD, and they are performing binning between the pixel covering this, these 3 spectral bands. And so I proposed to the Paris Observatory, is it interesting to manufacture such a filters? And so Paris Observatory funded us to manufacture these filters. So we have contracted a small company able to process and give the right coatings on 50 millimeter size windows. And we got so what we call the A filters, the B filters, the C filters, meeting the G band, the GBP band, and the GRP Gaia band. After we asked amateur to take a picture of 3 field of view, the 3 same field of view, which was published in an old Sky and Telescope publication. And in this field of view, so we record the picture in the 3 bands, and we see what could be the limited magnitude. And here are an example. You see on the top the G limiting magnitude. You see that we are between nearly 21 in the G band. In the GBP band, it's even better. We are just above 21, and in the GRP band, we are at 1950. And in fact, we realize that the GBP band enhances your sensitivity thanks to the fact you reject the night glow, giving you know a reddish, an infraredish background, and so you enhance your sensitivity in the GBP band. What we realized also is that thanks to the GRP band, when you have moon in the sky background is bluish, and so you reject it. And so these 3 filters give you also an opportunity to improve your sensitivity according to the sky condition. So, of course, and it was obvious, but we have to demonstrate it. We compare the magnitude we measure in front of the Gaia magnitude delivered by the respective spectral band of the Gaia catalog. And we show that even with the raw data, we have clearly a nice linear response with a slope of 1, and so it's working. It's very nice. So today, so this works. So amateurs are answering alerts. And last year, we entered the RAPAS, what we call the step 2, with the spectroscopy. The idea coming from Michel Denfeld from IAP. He was very interested in our network, but he told us, well, my interest is also when you get an alert, I want a spectrum. ion, the spectral energy distribution of the target. And so, of course, it's rather challenging. And so we start manufacturing last year of two prototypes. You know, in the field of amateurs, there is two family of spectrograph. The first one is the LP600, distributed by Sheliak. And with Sheliak and with an English supplier, we realized the prototype of LP200. We replaced the GRISM, which is a 600 groove per millimeter, by a transmittive grating of 200 groove per millimeter. And the other device, also well known in France, pushed by Christian Buil, was it's a design manufactured by a 3D printer. You have what we call Solex and Starex, a family of spectrograph. And in such a device, we, instead of having a 600 groove or 1,200 groove per millimeter or even more, we replace the grating by a small 150 groove per millimeter. And the purpose is to see if we are able to achieve high upper limit magnitude with 400 millimeter class telescope. And this has been done by Christian Buil with the very first equipment. He demonstrates with a refractor 80 millimeter diameter that he is able to achieve magnitude 15. Here you see Robin Leadbeater from UK, from the British Astronomical Association, using an 11-inch Celestron telescope that is able to meet magnitude 18.6 and showing clearly a nice band, also to be able to classify the alert. Is it fitted to a black body? Do we have emission line, absorption line? Are we able to measure a Z on the target? And here is the LP200 on the telescope Jean-Marc Salomon, which is a 60 centimeter telescope. And here are the very first tests we have performed with the Starex VLR. And clearly we see the Z and the shape of this alert, of this supernovae. And clearly, we have a nice tool. We could be prepared at the end of this year, maybe to start a small production of 5 units or up to 10 units. Here are also other. Okay, and so since mid of this year, we started to be plugged to Astro-COLIBRI. And today, so the observer in the network are delivering, so the GBP and GRP magnitude. Here are the last year supernovae we had in Messier 101. And today we have a spreadsheet I may show you. And if you are interested, you could get, yes, this access to the spreadsheets of all the Astro-COLIBRI alerts we answer. Yes, and so the last thing I want to share. So today we are a customer of Astro-COLIBRI. As Fabien showed you, we have a specific filter. The purpose was not to be overwhelmed by all these alerts, but to have a selection of alerts fitted to what we are able to do. And every Friday, all the observers are able to answer to a poll to define what would be the 10 alerts we keep for the coming week. And so we turn over through the alerts, either keeping new alerts occurring during a week, and cancelling old alerts which are not any worse to follow. So clearly, what we would like at the end of this year, we will have a third workshop. You are invited if you are interested to joining our workshop, either as a customer or to get the data we are able to provide. And what we have done, yes, Jean-Paul Godard showed it. It was a GRB 2408, 08 and 09, which give us the opportunity to issue our first GCN circular. And so we are ready to provide to GCN circular coming from the observer. And the nice thing is, from this observation, we have 3 observers checking and giving the beginning of a light curve on this GRB optical counterpart. We have some meetings through Zoom, and so clearly we are preparing next year, and clearly we will be able to provide the second batch of filters at the end of this year to enlarge the community. And clearly what I would like to propose you, if you are interested, we would like to establish partnerships with other countries to spread all over the world such capabilities through the amateur community. Thank you very much for your attention.